Hey there, Dr. Ray here, CEO of the Learning Liaisons, and in this video, you're going to be able to watch a recorded group tutoring session that we held with about 100 high school students recently. So once again, our math director, Duran, is going to be leading this group session where we have about almost 100 high school students here working on various SAT problems. So watch as our math director, Anderson, reveals one of our proven test taking strategies as destination plan follow, and then you can apply this strategy to any SAT problem you're going to counter to help you really dissect those word problems and hone in on exactly what needs to be done in the easiest way to increase your score. So once again, I'm Dr. Ray, CEO of the Learning Liaisons. I hope you enjoy this video. Make sure you like, subscribe, and comment on the video because we want to know your thoughts because we're here to help you. So always remember, it's all about prepping smart, not prepping hard, and we've got your back here at the Learning Liaisons. Enjoy the video and let us know in the comments what you think.
All right, everybody. It's 6:01 p.m. Eastern Time. Welcome, everybody. It looks like we have a ton of people here tonight. A good little group here. My name's Anderson. I'm excited to help you guys out today, and just want to make sure one more time that everybody can hear me before we begin. Just go ahead and use that chat box, because we are going to be using that to answer questions throughout the session. So one more time. Perfect. Sounds good, guys. Just got to make sure everybody's here and ready to participate. So with that said, we're going to go ahead and dive right in. Don't want to waste time. This is our first session together, and we're going to get right to it, right to the important stuff, right to the things that matter. That way we can leave this session knowing exactly what we got out of it and what we're looking forward to next time. So again, guys, I really got to thank you guys for being here. But before we begin, just want to give a couple of SAT updates by the College Board themselves. So the May 2 test, the May 2nd test has been canceled. All right. The April PSAT also canceled, and anybody who made a purchase for it is going to get refunded. So I'm sure that if you did register, you already received that email. So this is probably redundant information for you, but I still want to make sure that you're aware in case you didn't read your emails or anything like that. But also from the College Board, this is pretty important over here. So essentially what this said, it got cut off a little bit here, but the basics are they're looking forward to hosting the June SAT. Now, here's the thing. Chances are with everything that's going on, it's probably not likely that the June SAT is going to happen. However, they're making a promise that the fall SATs will happen no matter what. So the ones starting in August. So what that means for you is, well, prepare to either take it in person or some way to do it virtually. They're probably going to come up with a way so you can take it at home, which is going to be insane because it's going to be unprecedented. But the thing is, the times that we're going through right now require us to adapt, plain and simple. So I just want to make sure that you have that information just in case you're wondering or you're anxious about the future. They are for sure going to be hosting the fall SATs and beyond. The only question is whether or not it's going to be online or in person. All right. So with that said, let's dive right in here. What should you do about it? First off, thank you for being here. Being here is the first step in terms of getting prepared and making sure that you're prepared. Because again, practicing along and learning how to crush this math, that's going to happen here. I'm going to show you this 3-step strategy that's going to work for literally every single problem that you do, no matter what kind of problem it is. Because a lot of this that you're going to learn today, you do naturally with other things in life. And I'm just going to show you how you can apply like regular everyday logic to problem solving with math, as ugly as it looks. So what I want you to do is take advantage of the current situation and prepare. And what that means is with all of these tests being canceled coming up, especially the summer one likely being canceled too, you want to look forward into fall. And so, if you're going into your senior year, you're still going to be taking that test, right? And you just have to prepare and prepare and prepare and prepare. You have a lot of time at home right now. You have a lot of time to think, a lot of time to reach out to start study groups or ask me questions. And I want to make sure that throughout this entire time, you can lean on me whenever you want. You can ask me questions whenever you need to. Your parents can always ask me questions. I'm always here to make sure that you guys are informed. And that way, all you have to do is concern yourself with putting in the work and putting in the effort. I want to make it as easy as possible for you to put in that effort to prepare, at least on the math side. All right. So with that said, again, we're going to go ahead and crush some of these math problems. Before we do, I want to make sure that I introduce myself. Because obviously I don't want you guys just sitting there looking at some guy here. It's like, oh, who's he? You know, I've never seen him before in my life. I can't trust him. So why should I, right? So pretty much my name's Anderson. That's my first name. My last name is Duran. I got a couple folks here whose families I know. So Malagra, shout out. So that should be Camila there. So welcome. And, you know, I've been helping out with the SAT and tutoring the SAT for about a decade now. And it's been awesome to see, you know, students grow and really get into the college of their choice. That's really what it's all about. So, you know, again, we're dealing with this situation right now, but never mind. We're going to make our progress and do what we can to prepare for when things are back to whatever the new normal is. But just to make sure you guys know who I am again, I'm the director of math here at the Learning Liaisons. I've been the director of math here for quite some time now, about 2.5 years almost. And yeah, you know, I've been I was a classroom teacher. I still am teaching. I actually teach teachers now. So I started off teaching for Florida Virtual School. A lot of you guys probably have taken a Florida Virtual School class. And then I taught at a physical school for a year. And then I branched off. I did my own thing. You know, I started like my own like tutoring, or officially started my tutoring stuff, taught teachers, worked on some GRE stuff. And really it's all about making sure that people understand that math isn't such a bad thing. I know a lot of us, whatever way we feel about math, it has a lot to do with who taught us. And so if you had a teacher that just taught you straight out of a textbook versus one that really tried to get you to understand the bigger picture, it's going to show in terms of how you feel about math overall. And as some of us, you know, funny enough, understand math but still hate it. And hey, that's going to happen. But before I begin, I want to know how you feel about math so far in your life. Do you feel like you've been, you know, taught well up to this point? Do you feel like you just haven't been taught well enough to take this test? Is this completely new to you? Have you never taken the SAT before? So where are we at right now? Use that chat box or use the microphone. Where are we at right now in terms of math? Ryan says math is great so far. Oh, no, for the test optional admission cycle, I would really, that would be up to the individual universities. So I would keep an update. I'll keep us updated on that for sure if you're in the group. Matthew's never taken the SAT. Grace feels pretty good so far. So there's the next person. Perfect. I feel like I haven't been taught well enough in preparation for the SAT. Hey, Catherine, that's what we're here for. We're here to help you out. Haven't taken it yet. I don't think I've been taught and I feel way behind. Hey, that's a lot of folks here. Haven't taken it. I'm currently taking Algebra 2 honors. Feel good about math. There you go. The wording trips you up. Hey, no worries. I got your back here. Never taken the SAT before, but taking practice tests, and math is definitely a weaker subject. Hey, I'm glad that you took a practice test to find out. Megan says, I feel as though my current math level is not well reflected in my SAT. Hey, so that's going to be about how we apply it, right? So Megan, earlier I was talking about how we memorize information and how we apply information. The SAT doesn't grade you on how well you can memorize. It grades you on how well you can apply what you know. So we're going to talk about how we can do that for sure. So Brittany says she struggles in remembering things. All right, word problems aren't my thing for Veronica. So we're going to go over that as well too. I've never taken the SAT, but I've been taught well when it comes to math. I like to hear that. Tim says I've taken the PSAT, but I don't like math at all. Hey man, join the club. And I haven't learned some of the stuff that was on the test for Veronica. Hey, that's going to happen. So we're going to look at an introduction to 4 mini topics here, and I'm going to show you what we need to look forward to for the rest here. Oh, Nicole's in AP Calc right now? So you've forgotten algebra? Get out of here, Nicole. Hey, I actually taught AP Calculus. That was the funnest class I ever taught. That was it. So with that said, looks like we have a lot of folks here ready to go. I'm loving this. We're going to keep things really simple, guys. We really are. This session is going to be all about you. I want you guys to get an introduction to SAT problems, and I want to show you the 3 different difficulty types of SAT problems. I'm going to point out what makes an easy problem different from a medium, different from a hard, and we're also going to go through questions that require us to use a calculator and ones that do not permit us to use a calculator. Because on the test, there's 2 sections, calculator, non-calculator, and there are 2 types of questions, multiple choice and grid-in. So with that said, we're going to practice all those types of questions. So have a calculator with you ready. You can have your TI-30X, sure, go ahead. But when I say that there's a problem that we're not using a calculator on, just make sure to put it away. Be honest about it, because there's no point in cheating here. We're all trying to grow, so we need to have an honest look as to where we are. So with that said, today's theme, we're going to look at 4 different topics. We're going to learn how to tackle any type of math problem with this strategy right here. So give me 1 minute here to explain what this is, and then we're good to go. So think about it like this. Has this ever happened to anybody here where you start reading a word problem and you get a little nervous because maybe math isn't your 1000% strong suit, and you have that little impulse of just reaching for your calculator because you see these first 2 numbers here, and then you just start fiddling around hoping that your answer is one of the ones listed. Has that happened to anybody here? Happens to a lot of us, right? Yeah. And the thing is, that stems from that lack of confidence in math. And the thing is, in order for us to be confident, we got to be able to talk about it. All right. And here's the thing. Your calculator right here, it's a tool. All right. And when we think about tools, before we pick them up and use them, typically speaking, what you're going to do with it before you pick it up. Before you pick up a pencil, you're going to need to write with it. Before you pick up your cup of water, you're going to want to drink it, right? Before you get in your car, that you're going to be going somewhere, and where that somewhere is before you get in. And so the question is, why would you pick up your calculator when you don't know what you're supposed to do and why it makes sense? So do you see what I'm saying here? Your calculator, you're not supposed to touch it in the beginning of the problem. That's the last thing you're supposed to do. The first thing you're supposed to do in any problem, honestly, is not attacking. It's actually kind of just taking a step back and analyzing. You want to see the big picture first. And here's the thing. The big picture is not just going to snap to reality and just make everything magically okay. That's not how it works. The way it works is you need to start off by looking at only what you can understand. That's the first step in every problem. Destination. You want to point out, hey, what's going on and where am I supposed to end up? What's my destination according to the story? So only point out what you can easily recognize. Usually, that's only the stuff I'm reading in English. The numbers, don't read them. If there's an obvious math term that you recognize, sure, read it. But only talk about what you can recognize, kind of like using caveman speak, like pointing out the obvious things that you see and what makes sense. Because from there, that's when you start planning your solution. Think about it. In real life, we can't solve a problem unless we kind of know what's going on and why it's an issue to begin with. And so that's the first step. And once we understand it, once we understand the story and what we want the outcome to be, then we'll make a plan. We think about what we have in front of us and how we can connect it to what we need to get to or what we're trying to figure out. And that's where the math comes in. Because the thing is, every problem has given information and every problem has an end goal or an end result. And it's up to you to figure out what math builds that bridge from what you have to what you need to know. So far, everybody, does that make sense? Again, the first step is just a story. Then the second step, we're looking at how the math can help us tell that story. Because perfect. And once we have that, okay, guys, look, once we have that plan, yeah, please, you can take a picture of this. You can write this down. I'm going to be sending this recording out so that you have it. So I want you guys to kind of sit back, relax, and really take this all in. But here we go. So lastly, again, destination, what's the story about and what's my goal? Then what's my plan? How can I connect what I have to what I need to know? Once I have my plan written out and once I've confirmed that this thing makes sense, that's when I'm going to compute. That's when I'm going to calculate. That's when I'm following my plan. Because I know how this calculator is supposed to help me. So with that said, everybody, are we set here? Do we understand that our calculator is not the first thing we should pick up? All right, perfect. Sounds good. All right, so with that said, we're going to go ahead and dive right in. We're going to go ahead and dive right in. Like I said, today's theme, any type of problem, we're going to be looking at 4 of the main concepts here. And I'm going to time us. Notice on the top right of the screen, you're going to see whether or not you can or cannot use a calculator. And then it's going to tell you which topic we're dealing with and the difficulty level of the question. So I made sure to organize it all for you. You can take a picture of the problem if you'd like to. It's not necessary because you are going to get the recording, but I'm going to give us about a minute and a half for this problem here. And once you're ready, once you have your answer, don't reveal it. Just keep it to yourself until the time is done. So 3, 2, 1, and go. 1 minute and a half. We're looking at our final 15 seconds here. Remember, we're not penalized for guessing anymore, at least in these versions of the SAT. So if you have to take a guess, completely okay. Completely okay. We got 5 seconds here. 4, 3, 2, and 1. What are our answers? What do we got, guys? All righty, so a lot of us are pretty much agreeing on the same tone here, saying that B is the correct answer. Now, I want to make sure that everybody feels comfortable with providing their answer, no matter what it is. I don't care if you think you're right or wrong. I want you to be confident that you'll be able to understand whether you're right or wrong. Now, I'm going to say that one more time. I don't want you guys to worry about being right or wrong. I want you to aim to understand the problem better once it's revealed. Because again, it's not about getting one problem right. It's about growing and learning that you can get the next one right before you even see it. So here's how this is going to go. I'm not going to reveal the answer right now. I'm going to go through the problem and I'm going to ask some questions here. And then we're going to come to a conclusion together. So the problem states, if 12x plus 10 equals 2, what's the value of 6x plus 5? Now, for a lot of us, this may be a pretty straightforward question. And I agree with you. I'm totally there with you. Now, let me go ahead and just go over a standard solution that a lot of us may have thought of. Who here went with the trusty old technique of subtracting 10 on both sides? And then from there, we see that we have 12x equals negative 1/5 after we simplify. Oh, sorry, whoops. We have negative 8 right now before we divide. And then from there, we can go ahead and divide by 12 on both sides. And so we end up getting x equals negative 2/3. And then from there, we plug it in to 6x plus 5. Then we add 5. And so then we go about it. And so then we see that 6 times 2 gives us 12. Then we add, and then we have 5 here. And from here, this becomes negative 4 plus 5. And then we get 1. So who went that route? Who solved for x and then plugged it right in and then did their thing? There should be a lot of us, right? There should be quite a few of us. And that's cool, right? You know, a lot of us are used to seeing it like that. And I want to go ahead and use this and really show you what the SAT is all about. Remember, the SAT is not about what you've memorized. It's about how you can apply what you've learned. So let me go ahead and show you a different approach to this problem that will take you less than half the time that I just showed you. So let me change colors here. Let's go ahead and do red here. I'm gonna write the problem out. Now, everybody, let me ask you this. What is the goal of the problem? Is it to solve for X or is it something else? What's the goal of the problem? So look at this. This is already a good sign that we're going to learn a lot today. This is going to be a good way for us to grow. Because notice how some of us are saying solve for X and some of us are saying something else. So this is where destination, that 3-step plan, destination, plan, follow, it's too important. We have to always start off by understanding what our goal is and what the conditions are. My goal here, 6x plus 5. That's it right there. So 6x plus 5 is the goal of the problem. And what we're given, the condition here is just this other equation. So with that said, you need to understand that your goal does not have to, or your solution doesn't have to include solving for X. I want to show you something really cool here. Notice how we're trying to go from 12x to 6x and from 10 to 5. Anybody notice anything particular here about the relationship between this here and that there? Yeah, you can totally divide by 2. I can divide by 2 and I can get the answer instantly. But remember, everybody, if I'm going to divide by 2 on one side, where else must I divide by 2? On the other side, exactly. We know that. Cool. And 2 divided by 2 is 1. So it looks like we got to our goal in 1 step versus, I don't know, the same amount of time it takes to apply to college. So, yo, bro. This is why I miss teaching high school kids, man. So is anybody's mind blown right now? Because there's your first lesson on the SAT. It's not about what you know, it's about how well you can apply what you know. That is seriously it. I want everybody to write that down in their paper. It is not about what you know, it's about how to apply what you know. That's what it's all about. Not Gift, you're not wrong for that. You are not wrong for that at all. That's being creative. Because the thing is, unfortunately, a lot of us were taught in that same way, that same mode throughout our entire mathematical lives. Like, oh, you got to do it this way. A, B, C, D, A, B, C, D, A, B, C, D. And while learning procedure is great, it really is in some situations, in math, it can be toxic because it can close your eyes to creativity. And so there's lesson number 1 here. It's not about what you know. It's about how you can apply what you know. So who feels good about this so far, though? Who feels good that they can learn things like this? That's what I'm talking about. It's all about confidence, guys. Remember, it's not about being right or wrong. It's about being confident that we can get better from being right or wrong. All right. So here we go. Question number 2, going to give us 1 minute, 30 seconds. We're going to try out a medium problem. 3, 2, 1. Let's get it. Minute and a half. Go. And again, type ready when you're ready. Do not reveal that answer. This is a virtual high school classroom. I will kick you out. No. Here we go. Final stretch, 10 seconds. And again, if you're done early, check your work. See if there's an easier way or a faster way. And if you're not done, hey, we've got 3 seconds to make a guess. 2, 1, let's reveal it. What do we got? And let's be honest, if you were confused, hey, reveal that too. Go ahead, let's be honest with each other, because again, with all this going on, ain't nobody judging anybody. I can promise you that. All right, so a lot of us are saying C, because C's do get degrees. All right, so I'm not going to tell you whether or not that's right or wrong, but I'm going to go over 2 methods here. I'm going to go over the first method, which is the standard way that a lot of us have been taught. And then I'm going to apply that same creative approach that I did last time to get it done in a much faster method. So again, destination plan follow always though, guys, always. First, you start off by outlining, hey, what am I looking at? What's my goal? I'm looking at an equation. I'm not gonna read it. I'm just looking at an equation and I'm trying to find that 4x plus 3. All right, so here's what I'm starting with. Here's what I want to end up at. All right, so there's 2 main methods. Method number 1, a lot of us may, again, solve for x, go about it, and then plug it back in. No harm, no foul there. Subtract 1 from both sides to give us 12, and then x equals 6. Because from there, and I want to pause right here. Notice how if you didn't understand that this was the end goal, you could have been tricked into thinking that it's A. Now, this problem is pretty straightforward enough for us to not get confused like that, but imagine a harder question where all it takes is one moment where you're not paying attention and boom, you get a number halfway through your solution thinking that you're done. The problem just wore you down and you're like, oh, that's it. Let me pick it. You're wrong. So just want to make sure that you're being careful and always understanding what your goal truly is. But now that we're there, you plug it in and we'll get 4 multiplied by 6 plus 3, giving us 27. So did anybody use that technique or did anybody try to be more creative with it? Use it, Sasha. Nice. Veronica did that. Danny did it too. Cool. Hey, no worries, no worries. I'm going to show you guys how to think about it in different ways. So let me go ahead and rewrite it again. Here's the creative way that we can do it. I can start off by understanding I want to know the value of 4x plus 3. Right now, I have 2x and 1, and I'm sure some of you guys were thinking, well, if I multiply this by 2, I'm going to have a 4x, yeah, but I'm going to have only 2 after I distribute. And then if I distribute to the 13, that's going to be 26. But did that stop you? When you said, oh, if I multiply by 2, no, I don't have it exactly. I'm missing 1. Did anybody stop right there and just say, hey, screw it, I'm going to do it the other way? Okay, I like that you revealed that. You admitted to that, Ryan. Okay, so let me go ahead and capture that thought, though. You did that. You multiplied by 2 because you said, hey, I'm trying to get to 4x, so if I multiply by 2, but the only issue is that, hey, I have plus 2, not plus 3. So everybody, what do I have to add on to 2 to get to 3? Just 1. All right, we're good. Bet. Boom, 27. And all good. Hey, I'm starting to open some eyes here. I'm seeing some O's, okay. It's a good sign when you have students expressing emotion via text. I'm glad it makes sense, Grace. I'm glad it does. But that's how we do it. So who's feeling even better about this now, though? Because the thing is, it doesn't have to be super pretty and perfect. It really doesn't. You can start small with the variable and then manipulate the constants, because with the constants or with the regular numbers, all you gotta do is just add or subtract them. It's the variables you gotta worry about because that's your multipliers, your scalars. Perfect. I'm glad that you guys are feeling good. So that was question number 2. All right. Question number 3 coming right up. 3, 2, 1, go. Now we're in the medium section here of solving equations and inequalities. You got a minute and a half. Go. I see Dana. Hey, that's a good reflection though. But here we go, minute and a half. Final 5 seconds here. 4, 3, 2, 1, go. And again, yeah, even if you don't know, even if you're confused, hey, reveal that. It's okay to be vulnerable, guys. All right, so it looks like most of us have had the chance. I'll wait a couple more seconds to see who else wants to share as well. Sasha, look, hey, I'm not here to tell you whether you're right or wrong. Sasha, I'm here to help you teach yourself why we're right or wrong. All right, that's the goal here. That's the goal. So here we go. So let's read through it. You know, destination plan follow, as always. My first step is, again, just getting a feel for it. All this is doing, guys, all destination plan follow is doing for us is allowing you to not be rash, to not rush it. It's going to allow you to just take a quick 2-3 seconds to analyze. Okay, I see an equation and I'm asking myself, what's the solution to it? Boom, I've got my destination. I know exactly what needs to get done. I need to solve this thing. So with that said, let me take a moment here and write this out, my given information. Now, let me ask everybody this. What's unique about this problem? You know, what's the giant elephant in the room here? What's obviously unique about this equation? And if you don't know the name of the symbol, it's all good. It has lines. I knew someone wasn't gonna know it all the way. It's all good. Yeah, so that's called absolute value. So let's just go ahead and refresh ourselves there. That's called absolute value. It's called absolute value, right? So let's just go ahead and remind ourselves that is absolute value. Now, who knows what absolute value does? What does absolute value do? Because there's no reason to know what it's called if you don't know what it does. So it turns a negative to a positive. Anything in the absolute value is positive, makes the value positive. Everything is positive, 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 positive. Grace, boom, there it is. That is the dinger right there. Grace says the absolute value is the distance from zero. Grace, that is a perfect answer right there. And you guys aren't wrong for saying that it turns it into a positive. You're not wrong. But you're telling me by saying that what it does, not what it is. Because what it, and the thing is, I know I asked you what it does, but Grace went beyond and said what it is. And it is the definition of the distance from zero. And what do we know about the word distance? Can it ever be negative? No, distance can never be negative. Distance can never be negative. I can say that I can go 5 feet that way, 5 feet that way, that way, that way, that way, that way, that way, or that way. I can't go negative 5 feet. That doesn't make sense unless I'm establishing direction. So here's the thing. This right here, no matter what, it's supposed to be the distance from zero. Okay. I'm going to do one little thing here, and I'm going to ask you a question. Let me just look at this +1 right here, because it's not inside of the absolute value symbol. So let me actually just mess around with that +1, just to show you something really quick. I'm going to subtract 1 from both sides because we all know whatever you do to one side, you got to do to the other. So bye-bye there. And we're left with the absolute value of x minus 4 equals -1. All right, so everybody take 30 seconds. Don't type into the chat box. Don't say anything at all. I just want you to take 30 seconds and think about what could potentially be wrong here. Don't reveal it yet. Don't say anything, but just ask yourself, what could potentially be wrong here based off of what I know about absolute values? So again, don't reveal it, just think about it. What about this is fishy in terms of absolute value functions? All right, and 5, 4, go ahead and type it out. What do you think is wrong in terms of absolute value? I love that. I love that phrase there. It contradicts the entire concept. Exactly. We're saying right here that, hey, this is supposed to be only 0 and greater, because obviously if the number is 0, the absolute value of 0 is 0, right? But the thing is, this can only be greater than or equal to 0, but this is negative. Is there any way that a number that has to be 0 or greater can never be negative? Nope. And whenever we have a nope situation in math, we call that no solutions. Right? At least that's how I teach it. Whenever you see a big nope, then yeah, nope, no solutions. Boom. And so what does that make the answer? Well, it makes it D. The equation has no solutions. So with that said, who did it a different way, but still got something from this method? Yeah. So Gina, plug and chug. So you can also plug and chug. So let's talk about problem solving strategy here. On the SAT, again, some questions are going to be multiple choice. Some are going to be grid in. When it comes to the ones that are multiple choice, especially when it's like which of the following or the answer can be plugged back in. Hey, if you know how to look for your solutions, then you can plug in each of those answers for X and see if the left and the right sides matched up. What you would have seen is that the left and the right cannot match up in any of these cases, and that would have led you to pick D with a plug and chug technique. Now, let me just review one more time the ideas that we used here. That way we can use that moving forward. So the question was this equation right here. We wanted the solution. And now our goal was, hey, let's just solve an equation. You know, it's just a regular everyday equation. So I'm going to try to get the X by itself. You know, let's go ahead and pretend that we're trying to get that X by itself by subtracting 1. The big issue is this right here. This symbol tells me that whatever's inside of that little bar, those 2 bars, that absolute value, it's going to tell me how far that number is from 0. And how far means distance. And so therefore, no matter what, this will never be negative because distance can never be negative. And so the flaw in this problem is that you have one side of the equation that can never be negative, but it's somehow supposed to be equal to a negative number. And so with that said, that's a big little doesn't make sense. This is always going to be 0 or more. This is definitely always going to be -1. So no possible way that that matches up. And that's why we got no solutions. Boom. I'm glad I could help you out. No worries. So guys, this is why it's important to ask questions and say you're confused. I know some of us may be ready to move on to the next problem, but I'm sure that we all appreciate being able to learn and grow together, especially during a free session like this. So please don't bother, worrying about asking questions. Just ask them. It's only going to help you, and and anybody else who's maybe shy enough to not ask. So with that said, we got question number 4. We got a hard one coming here. Give me a yes if you're ready. We got some competitors in here. All right. All right, let's get it done, guys. 3, 2, 1. Let's get it done. Number 4, or yeah, question number 4, but this is number 6 from our sample set. Minute and 45 seconds here. Go. About 45 seconds here. And if you're done early, make sure you're going through your work and making sure that you can convince yourself that you're right. Because remember, it's about that confidence. It's not about just getting to an answer. It's about confidence. So 30 seconds here. All right, here we go. 4, 3, 2, and 1. What do we got? We got A with a question mark, C coming in here, some more capital and lowercase a's, another C. Okay, so it looks like we have a little competition going between C and A, might be. But it kind of looks like A's drowning out the conversation right now. Is anybody here not sure? Because I'm pretty sure someone here shouldn't be sure. So thanks for being honest. There it is. It's about being honest with yourself. Because again, you guys are here. I'm here for y'all, not the other way around. So I want to make sure that I can be here for you, but you have to reveal that you're confused. You have to be honest. All right, perfect. Looks like we've all had a chance to share our solutions here. Let's go ahead and go through it. Again, I'm not going to tell you what the answer is. I'm going to review it and show you how you can teach yourself. So I'm going to read the question again. I'm going to read it in a way that's in English. So destination, we have 2 values on a number. Okay, I'm already reading that. And if I'm getting confused by that, no worries. We can try to break it down a little bit. 2 values is just another way of saying numbers. So you can just say 2 numbers on a number line. That's all we're saying. So 2 numbers on a number line are 1 unit away from the number 10. Okay. Which of the following equations, when solved for x, give the 2 values being discussed? So this is a pretty complicated question because there's not a lot of room for us to really just talk about it in English, right? So this is where this takes a little more mathematical skill to really break down. But let me break it down for you as best I can to anyone who may not even be at this level. Let me just break it down for you. They're saying that we have 2 numbers on a number line. So let's say we're looking at a number line and they're both 1 unit away from the number 10. Guys, let's ask ourselves, what are the 2 numbers that are 1 away from 10? 9 and 11, right? That's pretty, that's a rhetorical question almost. And you're almost offended by me asking that, but it's all good. 9 and 11 will be our answer. So we know what the answers are. But remember, they're not asking us to figure out what those numbers are. They're asking us to figure out what will reveal what those numbers are. So here's how we're going to take care of this. If we're trying to figure out which of the following equations represents this right here, then we have to ask ourselves, well, we're talking about distance. And here's why I know that. Here's the key phrase. I'm going to go ahead and highlight it in green now. They're both 1 unit away from the number 10. Does that specify negative, positive, or does that just sound like a distance? Does that specify negative or positive, or is it just a distance? That's the question there. Yeah, it's just a distance, right, guys? So yeah, what I'm saying is then we should already be thinking about absolute value here, because they're saying, hey, what's the distance from here to there? So with that said, what are you subtracting? Well, you're subtracting whatever this number is. I'm going to say it's X for either one, doesn't matter. But I'm going to take that number, subtract it from 10, or 10 minus X, either way, doesn't matter, because we're going to take the absolute value of it. Remember, the absolute value just produces the positive result. So it doesn't matter if I'm subtracting big minus small or small minus big. It doesn't matter, because at the end of the day, if you use 9 or 11 in either case, it's both going to result in 1. Doesn't matter. So that's why A is the answer. Because at the end of the day, the distance between X and 10, the distance between these two numbers, that's what that means. Again, absolute value means the distance between these two numbers will be 1. That's what that's telling us in layman's speak. It's a little more complicated than that, but I'm kind of watering it down to help you get accustomed to listening, to seeing this way. But do we see what's going on here? Why this equation is the one that makes sense? Because I'm going to go over the answer choices up next and show you why those are wrong. Yeah, no worries. Because this first one, again, I'm just telling you why the right answer is right is not always the best way to go about it. I'm going to go and show you why the wrong answers are wrong now. But I needed to just start off with A, because that's the right answer. Let's go and go about why B, C, and D are wrong. First off, look at B. It says the absolute value is somehow supposed to be equal to -1. Everybody, is B wrong? Yeah, B's wrong, right? B's wrong for sure. Because again, notice what I'm doing here. I am using what we know about absolute values and applying it to talk about what we're doing. Again, I'm gonna sound like a broken record, but I'm gonna brainwash all of you. It is not about what you know, it is about how well you can apply what you know. The SAT used to stand for Scholastic Aptitude Test. And the thing is, aptitude is all about how well you can use what you know in different situations. So in short, the SAT is an intelligence test. It's about how well you can use what you know in different situations. Mathematics, reading, writing, essay, all that stuff. So that's how life works. It's about how well you can adapt. So this is what you're getting into. Now over here, for C, what you'd be seeing here, no pun intended, is that the distance that X plus 1 is from 0 is 10. That doesn't describe what we're looking at. This does not describe what we're looking at. We're looking for the difference between X and 10 being 1 in either direction. Again, that's this right here. And then D, X minus 1 equals 10. This is similar to C. It's not going to work out very well. Because again, this is saying that the distance between X and 1 would be 10. Again, that's not what we're looking for. We're trying to say the difference between X and 10, the distance between them being 1. That's what we're trying to say. So that's why B, C, and D are wrong, and A is correct. Give me a whoop whoop if you're having a little bit of fun right now. Give me a kind of like, I was doing well so far, but this problem is holy wow. Because I'm doing this on purpose. I want to reveal, again, how we can go from those easy standard questions to those mediums to those hard questions. Because notice how I really had to get into those roots and really talk to you guys about what absolute value meant before we can get this one right. So on your keyboard, shift and then that backward slash. It's the one that's facing up. All right, everybody. So there it is. Let's go ahead and keep things simple. Again, keep things simple. Destination, plan, and follow. This is always your first step. You always want to know the story and the goal of the story. So pretty much you're trying to just point out the question and the conditions. That's what you're trying to point out. Again, what's trying to happen? What do I need to happen? And what am I bound by? Like, what are the conditions? What are the details that I need to abide by? Then once I know the details and once I know the end goal, then start to finish. What I have, what's relevant, honestly, and I need to take that to where I'm going. And that's when you follow your plan. So after that first set of problems, who here is starting to develop a slight appreciation for destination, plan, follow? And answer that while Veronica's question gets addressed. So she says, I don't know how to type the absolute value signs. Yeah, boom, there you go. Yep, you got it. All right, and a lot of us are seeing the virtue here. I love it, I love it, I love it. Let's go ahead and go into the next set of questions, everybody. This first set is going to be an easy type. We're now going to be looking at ratios, rates, and proportions. So with that said, 3, 2, 1, let's get it done. Go. So this is question number 1 for ratios, rates, and proportions. I am pausing here and go. Minute, 30 seconds. And guys, remember, even if you're sitting back there just saying that you're going to wait for me to do the solution, I know there's always at least one person. Please don't. Try every problem out. I promise you, it's okay to be wrong. I'm here to show you how you can go from as far as you got to the complete answer. That's what I'm here for. But if you don't try, I can't take you from anywhere, okay? So just give it your best, guys. I'm here for you. All right, we're looking at our final 10 seconds here. 3, 2, and 1. This was a calculator grid-in question. We have the answers 3 being floated around, 24 being floated around, 3.5. I'm writing down all of the unique answers that I'm seeing. It looks like a lot of us are saying 3 though, but I want to make sure that everybody has a chance to be heard. Even if you don't believe you've gotten to an answer, again, be honest. You know, I'm not the type of teacher here that's going to give you points for writing out what everybody else wrote out. Again, like notice how I'm not like congratulating or putting anybody specifically down. Like that's not how I do things. I want you guys to really enjoy the growth process, and that means being okay with being wrong. All right, so it looks like everybody had a chance to really chime in there. Thank you guys. I really appreciate the participation. It looks like you guys are finding it easy here, and I appreciate that. So with that, Veronica, I'm going to address that right after this question. So just copy and paste that for me, please. But so Jerome, he can solve at least 8 math problems per hour and at most 14 math problems per hour. So if I'm reading this for the first time, fresh, I'm already saying, okay, look, we're talking about Jerome. And we're talking about him solving math problems. And 2 keywords that I want to really emphasize here are least or at least and at most. Now I'm going to ignore those numbers, the 8 and the 14, just ignore that for now. Because again, I'm going to say this a million times. It's not about what the numbers are. It's about what they represent. Okay? It's not about what the numbers are. It's about what they represent. So I'm reading this saying, hey, Jerome can solve at least this many math problems in 1 hour, or at most this many math problems per hour. I'm not going to read the numbers because I'm not trying to think about what the numbers look like. I just know that these are numbers. That's it. Next, based on this information, what is a possible amount of time in hours that it could take Jerome to answer 42 questions? All right, so if we're doing caveman talk, what am I reading here? I'm reading about Jerome who can solve math different speeds, slow and fast. And I want to provide the information, or the question is, what's a potential amount of time that it could take him to answer that many questions? So we have slow speed, fast speed, and we're good. So let's ask ourselves, what is it that we're trying to solve for? And could there be more than one answer? Yeah, there could be potentially more than one answer. There really could be. Really could be more than potential one answer, because the thing is, we have the given information that I'm going to write out. Because before you write out the given information, let me just really say this again. You have to understand what the question is. There's no point in writing out given information if you don't know that it connects to your answer at all. So the question is the most important part first. We're trying to solve for the number of hours it takes. And I love that, guys. You guys are really coming together. So we're looking for possible number of hours to do 42 questions. Do you guys notice how I'm not even writing 42 math problems? I just wrote questions. You could honestly shorthand it on the test and just write Q's. Like, it's really up to you. The less you write, the better. Really, seriously. The less you write, the more time you're saving. So we're looking at the number of hours to do 42 questions. Well, if that's our goal, then my question is, before I look at the given information, my question is, do I have any information that is related to hours or questions? And what would you guys say to that? Is there any information that's related to hours or the questions? And if so, what is it? Let's see, we have a lot of diverse answers here. We said 8 and 4 are hours. So Catherine, unfortunately, that's not actually it. But let me go ahead and show you how we can redirect that thought here. So when we're looking at the question here, I'm going to highlight it for us. Catherine, do you see how it says 8 math problems per hour? And then it says 14 math problems per hour. The key word here is the word per for both of them. Because when we see the word per, Catherine, that's basically saying, hey, every hour we're doing this many problems. Oh, so it looks like it was just a typo. So I got you. And it's 14 math problems per hour. But yeah, cool. So that actually is a ratio, but it's not going to be used in the way that we think. All right. And here's what I mean. Here's what we can do. If we're going to go about this with a ratio or a proportion, we're going to have to do 2 separate proportions. And here's why. We can set up one proportion where we compare, again, in the numerator, number of problems, and the denominator would be the number of hours. Here's something about proportions that I want to teach you, and in case you didn't know this. Here is the number 1 rule for proportions. I'm going to write it right here in red so that everybody can write it down. The number 1 rule of proportions is you have to make sure that you compare the same items in the same way. All right, compare the same items in the same way. And here's what I mean by that. If in this proportion, I'm going to say that we have problems up top and the hours in the denominator, the problems will be on top here and then the number of hours in the denominator. Compare the same items in the same way. So think about it like this. If I'm starting with this first proportion for the 8 math problems per hour, here's what I'm doing. If I can solve 8 math problems in 1 hour, because per hour, what that means is every 1 hour. Well, let's look at the right side here. I can do 42 problems in how many hours? So I can say H hours here. So notice this would be giving us how many hours it would take if we're going at 8 problems an hour. And similarly, we can find the other amount of hours it takes on the other side with this proportion. 14 problems in 1 hour equals 42 problems in another amount of hours. I can say, M hours if I wanted to. This is the right way to go about it, because this first proportion is going to show us, hey, if I'm working at this speed, 8 problems an hour, how many hours? And then this one over here is going to tell me, hey, if I'm working at this speed, how long is it going to take me in hours? And that's going to be my boundary. At my fastest and at my slowest, this is how many hours it'll take. And so then the answer would be anything in between. So notice how I didn't actually solve it yet, but does anybody have sense about this in terms of what I just said? Again, solve one proportion to get how many hours at 8 hours or 8 problems an hour. Then the other proportion to get the number of hours at 14 problems every hour. That'll be the fastest and slowest that Jerome can work, which means that our answer will be the hours in between. Inclusive, exactly. Anything between 5.25 and 3 inclusive. And I'll show you why in a second, because it's all about reading the context. But let's solve really quick, everybody. Help me out, everybody. Grab your calculators. We got 8H and then 42. So if we have 8H equals 42, everybody, what's H going to be? Everybody, what's it going to be? 5.25. Do we agree with that? Boom. All right, we all agree with 5.25. So that's 5.25 hours. All right, great. Now over here, cross multiply and divide again. 14M equals 42. Divide by 14 on both sides. Everybody help me out. M equals. All right, thanks guys, appreciate it. So we have 3 hours at fastest and 5.25 hours at the slowest. Now we can include these numbers. 3 and 5.25 are both valid answers because it says at least 8 and at most. So the hours that we get through those paces, those are inclusive. So the answer could be 3, it could be 5.25, and it could be anything in between. So 24, unfortunately, would be incorrect. But the 3.5, that would work. 3.6 would work. 3.7 would work. 3.8 would work. Guys, in this situation, why is it okay to use a decimal for an answer here? Why is it okay? Because usually when we think of real world questions, we can't use decimals. But why is it okay here? Exactly, because it's hours. You know, you can have a decimal hour. You can have half an hour. It's not like we're talking about people. Now that would present a humanitarian issue, and we can't say that, oh, we can use half a person. Be very careful there. Those are ugly situations. But when it comes to time, we can definitely talk about portions of it. Now, Alexandra, you had a very good question. I'm going to answer that right now. On the actual test, would it be quickest to find the answer just one of the ratios? Absolutely. And it's all about the context. Here, the context says at least, at most, So either ratio could be used to solve this. Absolutely. Either ratio could have been used. It's all about reading the context though, because I didn't want to start off in the beginning and say, oh yeah, just look at this. This is all you got to look at. And then, lose some of you guys. I know that not everybody's thinking about that. I'm trying to take everybody from where they potentially are, from where they need to be. Yeah, gift. Yep. Both answers could have been right and anything in between. 4 would be correct. 4.5 would be correct. 4.8 would be correct. Honestly, anything between 3 and 5.25 inclusive would work. Hey, you're welcome, Grace. No worries. So we have just about, I want to say like 20-ish minutes here, and then we're going to call it a night, and I'm going to show you some other goodies here. So we're almost done here. I am so glad that you guys are being really, really cool about this. This is nice. All right, everybody. So question number 2 coming right up. 3, 2, 1, a minute and a half. Go. Remember, destination, plan, follow. You can use a calculator here. This is a grid-in. All right, we're looking at our final 10 seconds here. Final 10. 2, 1, and let's go. What do we got? All right, looks like some of us are a little stumped here. Looks like only 5 of us are sharing right now. Hey, it's all good, guys. Like, if we're confused, if we're taking a guess, let's be honest. Let's be honest. Be honest. Because this is a medium question now. So we're going to have to apply our ability to read context. Plus, we have to express that we know our math. Like, that's what medium problems are. It's like that mixture between like simple step problems and hard problems. Obviously, that's why it's called medium. But what we're looking at here is, hey, we're going to have to interpret something, and we're also going to have to use our math skills to solve. We have to do it at the same time simultaneously. Because if you forget to think about the context or the conditions, then something of the math is not going to make sense in the end. So let's just go ahead. Let's stop talking about it. Let's get to it. So the thermocline in the mesopelagic, well, I'm already reading this and I'm like, right? Like, did anybody else just start reading this and you're like, why did I join this session today? Right? So exactly, right? So the thing is, here's the thing with the SAT, if it's a big word that you've never heard before ever, chances are it probably doesn't matter. All right, I'm gonna say that one more time. If you see a ridiculously big word that you probably never heard before on the SAT, don't worry about it. Don't stress yourself out. Remember, only focus and give your attention to what you can immediately recognize. Caveman talk. So the something in the zone in a part of the ocean. Okay, I don't care what thermocline means or mesopelagic zone means. All I know is that we're talking about a zone that's in the ocean. Can we imagine some part of the ocean, everybody? can we imagine some part of the ocean? And I think that's pretty rhetorical, right? Like, of course we can, we can imagine what the ocean is. So again, stick to what you can understand. That's all I'm going to focus on. So the zone in part of the ocean has a temperature of this when we're this far below the surface, and a temperature of that when we're that far below the surface. So for every, for every 100 feet of depth, so every time we go down 100 feet, the temperature decreases by this many degrees Celsius. And D is a constant. What's the value of D? And I'm going to highlight that in a different color here. So there's two ways of going about this. We can go straight forward, read start to finish, or we can, once we read the problem, really look at the number here and say, hey, what's the value of D? Or the question here, sorry. What's the value of D? So seriously, guys, watch this. I want to know what the value of D is. That's the goal here. All right. I need to understand what D is, because there's no way that I can solve this question without more information. We can clearly see that. If they just ask you a question, what's D? Well, what am I looking at? An equation, a word problem, like what? So we're clearly looking at a word problem, and we see that D is revealed right here. Every time we go 100 feet down, the temperature goes down by D degrees Celsius. Okay, so I have a lot of information on D now. Again, I'm looking for D, and D is every time we go down 100 feet, we go down by D degrees. That's my given information. But let's keep exploring, because this is still not enough. This isn't obvious yet to me. So let's see what else we can look at. Well, I also see that the ocean has a temperature of 25 degrees Celsius, 200 feet below. So at 200 feet below, the temperature is 25 degrees Celsius. Okay. And then I also see over here that I can highlight in green, it has a temperature of 5 degrees Celsius, 600 feet below. So if I'm thinking about below, so below the surface, this would be 200 feet down, and then I'll go even further down for 600. So what I'm doing here is I'm applying one of my trusty old concepts or paradigms here. And this is called the following. One moment. This is called when in doubt, draw it out. That's the technique there. When in doubt, draw it out. So what I'm saying is, okay, I know that every time we go down 100 feet, we go down D degrees. So with that said, everybody, look at this. Here we're at 200 feet below. Here we're at 600 feet below. My question is, how many times do we go 100 feet down? How many times do we go down by 100 feet? From 200 to 600, how many times do we go down by 100 feet? 4. Is that agreeable? Do we agree with that? Are you sure? Let's work with each other here. Let's see, 200, so 300, 400, 500, 6. Okay, cool. Yep, it's 4. So we can feel pretty confident about that. So we go down by 400 feet, or 100 feet 4 times. Because remember, we're told that we go down by D degrees every 100 feet. And so that tells me that we went down by 4 times D degrees. Does everybody understand that? Remember, the question said, every time you go down by 100 feet, you go down by D degrees. I see that we went down by 100 feet 4 times, which resulted in us going down by D 4 times. Does everybody understand that right there? Yeah, because we went down by 400 feet, we're going to go down by D 4 times. Because again, it says every 100 feet, D degrees. Since we go down by 400 or 4 groups of 100, then for sure, we're going to go down by D 4 times. So notice how I'm talking in English here, right? Now it's making sense. Hey, that's what I'm talking about. That's what I'm talking about, Brittany, Norb. So now what I'm saying is well, what would 4 times D be? Because remember, this is showing us how many feet down we went. And this should tell us how many degrees down we went. Is there anywhere here that tells us how many degrees down we went by? Nora, where'd you get that from? 20, where does that come from? I love it. Yeah. We go from 25 degrees Celsius to 5 degrees Celsius. So this is going down 400, and we ended up going down by 20 degrees. So what this means is that 4 times D and 20 degrees, is it true that they're the same thing then? Is it true that they're the same? Because I have one person saying yes, but do we all agree that they're the same? And it's okay to be not sure. It's completely okay. Again, I'm not here sitting, I'm not going to be sitting in front of you pretending to be some, like, you know, some deity of a teacher. You know, if one way that I'm saying something doesn't make sense, I need you guys to let me know, because I'm going to do my best to explain it in another way. Yeah, so Brittany, 4D equals 20. So let me go ahead and approach you guys with that. And here's why 4D equals 20. 4D equals 20 because the problem states that every time you go down 100, we go down by D degrees. So we went down by 100, 100 again, 100 again, and then 100 again. That's how you go from 200 to 600. You go down 400 times. So with that said, again, remember, every 100 translates to a D. So what that means is we have 4 of those hundreds. So that means we went down by 4 of these Ds. And if you look at this, it says that we went down by 20 degrees. But remember, every 100 feet translates to 1 of those Ds. So we're saying that 4 of those Ds is the same thing as a decrease of 20 degrees. And so that's why when we do our math here and just divide by 4 on both sides, the D equals 5 degrees Celsius. And that's why 5 is the answer. So that was a second way of explaining it. But again, I am in no way sitting here saying that you are guaranteed to get it the moment that words come out of my mouth, right? I'm not here to guarantee anything like that. But I am guaranteeing that if we look at different ways of solving problems and how to open our eyes to doing problems in different ways, it's going to go better and better for us. Again, I am not here telling you that there's one way or the highway. Oh, no, I wasn't saying 4 is the answer. I was saying that it was going down 4 times, which would then translate to that 5. Yeah. No. We wouldn't have been able to divide 25 by 5 because that would give you a ratio. And so we would only be able to apply that in the sense of a ratio, but this isn't a proportional relationship because it's linear. It has a starting value. It doesn't start at 0. So it's a little more complicated than it might seem, Catherine. But in this problem, it's a lot more logical to go from an intuitive perspective in saying, hey, okay, if every 100 feet decrease translates to D, then I need to see how many groups of 100 there are and what temperature decrease that applies to, and you do your thing. Now, Gift says she had another way. Go ahead and type out how what your other way was if you'd like to. That way we can read it while we look over the next question, because I love seeing other ways. And if you don't want to, it's completely okay. I know you're saying okay, like, oh, I gotta type now, but it's all good. We're gonna dive into question number 3 here. This one's gonna be a hard one. So with that said, I'm gonna give us a minute 45 for this one, an extra 15 seconds. And from there, we're gonna work on the question together. So 3, 2, 1, and go. Minute 45. Remember, guys, look for the relevant information. This one is not as bad as you think. Go. No idea where to start. All right, so here's what I'm gonna do. Because the thing is, we're running really close to 7:30, and so we have like a little bit of limbo time. What I'm gonna do is I'm gonna allow you guys in this room. I'm gonna give you all together an extra 3 minutes to work together to get to the answer. And I want a confident answer. And if you think that you know it and you absolutely know it, I want you to attempt to explain in text how to get there. Oh, yeah, thank you for that gift. I'm gonna read that right now too. So guys, work together to get to that answer. I want you to convince your teammates here that your way makes sense and that they can adopt that method. So I'm going to sit here silently for 3 minutes. I'm going to count it down. Go. And let y'all work together. And you can use the mic if you'd like to, just to mute yourself if you want. Yeah, you can write the answer too if you'd like to. But you can turn your mic on and talk to each other. Do your thing. I want to see you guys work together here. Guys, go ahead and start off by clearly identifying the goal of the problem.
So we're trying to figure out how many minutes it takes. I know it doesn't say like the minutes on the table, but hold on, let me move my like chat over. So it's saying like how the average driving speed with no traffic delay. So the 25 is miles per hour. And then, so I don't know exactly if it's right, but you know, we can talk about it. I know that you have to like times, I'm assuming it's the 45 because that's the miles per hour because the distance wouldn't change by 0.4 because it's 40%. So if you add that or times 0.4 times 45, it would be 18. I don't know if that's right.
What I was doing is I divided, because you have the average speed and then you have the distance, and speed is in miles per hour. So I divided 45 by 12 to get 3.75, and then I multiplied that by 0.4 because it's 40%, get 1.5 minutes, but I feel like that's completely wrong.
Ooh, I don't know who just spoke, but that was so close. You just misstated one operation. Just think about that one more time. That was really good.
I think
45 times 12.
No, 45 divided by 12 because that gives you the amount of time it takes. Okay. Oh, am I multiplying? 12 divided by 45. Okay.
Divided by 45 times 0.4. What are you talking about?
Oh, yeah. I'm stuck again. And I'm Nor, by the way.
Hello, I'm Duran. So we're doing 45 divided by 12 times 0.4.
That would give you 0.1. I have no idea.
This is awesome to see. This is awesome. You guys ready for me to step in?
Yeah, please.
No, like seriously, you guys are dope. Like this is good. So let's go ahead and let's read through it. I'm gonna start off by going straight to the question itself because there's all like you see this problem, right? There is a bunch of text. So when it comes to a problem like this, here's the thing. We're going to talk about test taking strategy in another session in terms of how to handle each individual question on test day. But when it comes to a question like this, typically you're not doing this until you're like done with your test. You're skipping questions like this until the end, because the goal is, hey, I only want to answer the easy ones first and build my confidence. And then when it comes to a vomit-inducing swirl of pixels like this, I'd rather leave it for the end. So anyways, when we look at a question like this at the end, I'm looking at the question directly. This is, an exception to the rule, where if you are confident in your ability to identify the question and then work backwards to find the information, cool. But this is a very advanced technique. I'm starting right at the end here. How many more minutes would it take to complete the route if he starts the drive at 6:30 instead of 6 a.m.? So if I read that question, this is exactly what I got from it. The phrase, how many more? What does that translate to, everybody? How many more? What does how many more translate to? So let me use that in context. How, if you have 10 apples and I have 6 apples, and the question was, how many more apples do you have than I do?
The difference?
Difference, for sure. So remember, when in doubt, use it in context. So how many more? Use it in a simpler context. Because here I'm seeing it, how many more, and then, hieroglyphics. But in real life, how many more is 14 apples than 10 apples? Oh, that's 4, the difference of 4, boom. So we're looking at difference. So this tells me that I'm looking at the difference between time, or the difference between the 6:30 route and 6 o'clock route. Can everybody agree with that? Like, that's what we got from the question? Without reading the context yet, without even knowing what we're dealing with, do we understand that how many more is this than that? That means the difference. That means subtracting something from another. So again, I'm not trying to trick anybody yet. I'm just going to talk about what we can identify. Booyah, gift, exactly. Intuitively, you guys are awesome. This is why I love high school students, because you guys think intuitively so much more than a lot of other age groups. You guys are saying, hey, look, if that's what we need, then let's just find it and move on with our lives. That's why I love high schoolers. You guys are apathetic to a very good degree sometimes. So with that said, we're here and now we're going to look at what the difference would be between 6 o'clock and 6:30. So here's my current goal. I'm going to go into the context and look at every difference between 6 o'clock and 6:30. What are the differences between the two? So I'm going to dive in here. Let me make this a little smaller so I can highlight this better. And I'm going to read through quickly. The school bus morning route, I see that we have a big table, so I'm going to come back to that later. And over here it says, school bus driver drives the bus to each stop and then to school every day each morning. Table of bus shows the distance in miles, the average driving speed in miles per hour when there is no traffic delay for each segment of the drive. If the bus driver starts at 6 a.m. If he starts at 6, he can drive at his average driving speed with no traffic delay. Ooh, I know I heard that before, that phrase right there. So 6 a.m. means no traffic delay. Can we all agree on that? That 6 a.m. means no traffic delay? Sweet. Guys, do you notice how I skipped all of that information? I said, I'm only concerned about 6 a.m. versus 6:30. Until I read the 6 a.m. and 6:30, I don't care about what this thing has to say. I'm only looking for what I need to read. And that's how we Google things in real life, right? Like if I'm trying to find out like the recipe for, like baked potatoes or something like that, I'm not going to stop and read about bacon, as tempting as it is. But some of us will get tempted by bacon. It is confusing, Sasha, and that's why it's so important to only care about what we're looking for. So there we are. 6 a.m. means no traffic delay. Now, what do we know about 6:30? I'm going to use green here to only highlight things about 6:30. If he starts the drive at 6:30, travel time from stop B to C increases by 40%. due to slower traffic. So with that said, oh, look at that. I have everything I need for 6 a.m. and 6:30. What's the only difference between 6 and 6:30? What is the only difference? Let's be really a lot more specific there, Ryan. So 40% increase in time for what? The entire trip? Yeah, there we go. From B to C. From B to C. Specifically, the problem says from B to C right here. Increases right there. Let me just erase the question here. That way I can really show you guys. So again, stop B to C increases by 40%. So here's the goal then. If I knew the time from B to C, what would I have to do to that time to get my answer? Sasha, you're already on the ball there. Yeah, exactly. 0.4, quick as heck. 40% of that. We want 40% of the time from B to C. That's exactly what we're looking for. Because once we have that, that's it. The party gets started and we're done. So we're looking for 40% of the time from B to C. That's what we're able to get out of there. Notice how we still haven't looked at the numbers yet. It is not about what the numbers are, guys. It's about what they represent. That's what I've been trying to teach you this whole time here. That's how you can really keep yourself stress-free during this. And I know it's not easy seeing it for the first time, but I'm hoping that I'm opening your eyes to the possibility of getting to this level here. So we're going to find the time from B to C. We're going to take 40% of that, and that's my answer. That's my plan. I know I'll be good. This is the epitome of destination plan follow and a hard question. So let's go back now and let's figure out how to get the time from B to C with no traffic. I'm looking right here at this table. Very clearly it says stop from B to C. I clearly see that we have a distance of 12 miles and the miles per hour average speed being 45. Now, what this makes me think of is one formula in particular that's going to help me out here. And the reason that I know this formula will help is because we're given distance and what kind of a unit is that? Miles per hour. Starts with an R. Spot on, Matthew. It's a rate. Exactly. Nope, Tasha, we don't need to find the average. We don't, not at all. Because we're given a distance here and we have a rate. And if we want to know the time, well, we're going to be using our formula distance equals rate times time. This formula is going to save us here. Because if we want to find the amount of time from B to C, well, the distance that we have is 12 miles being equal to the rate 45 miles an hour multiplied by the time it takes. Now let's be very careful here, everybody. The time that we're going to find, what are the units for the time that we're going to find? In this equation, as it's written out, read it out. We said this 12 was miles. The 45 is stated in miles per hour. So that means that the time here will be revealed in hours. So we need to think ahead for a brief moment and tell ourselves, whatever we get for time, we have it in hours. So what should we do once we have the time? Nora, you're on the ball. Nora Maria, you're awesome. Yep. So you need to convert that to minutes. Boom. Exactly. And we multiply by 60 to do that. So that's my plan again. Let's solve this. It's going to be in hours, but I want to turn it into minutes so that I can take 40% of it. Because again, my answer, it needs to be rounded to the nearest minute in case I didn't go over that briefly. So I apologize if I didn't go over that information there. But we want our answer to be in minutes, and that's why it's necessary to convert back to minutes. So without further ado, now we're going to follow our plan. Notice how we can follow our plan calmly now. Find the minutes from B to C and multiply it by 40%. This is me finding the minutes from B to C. I have to first go through the hours. So T equals 12 over 45 hours. Just like we said, I'm going to multiply this by 60 minutes per hour because it's going to cancel the hours. And it's going to turn this into 12 times 60 over 45, which is the same thing as saying 4 over 3. And then 12 divided by 3 is 4. 4 times 4 is 16. So this becomes 16 minutes. Obviously, you guys could have used your calculator, which I hope you did, but you didn't have to do that. So now, again, this is the time from B to C. So far, everybody, minus the computations, just the concepts, the intuitive reasoning, is that still good with everybody? Does that process make sense? Because that's the most important part. I could care less about the numbers. You're going to see confusing numbers all day long. I care more about the ideas that we talked about. And Gift, thanks for being honest. Kinda, I like that. So think about to yourself, what would make it more solid, whether it's more practice or just more explanation, and then reveal. But there we are. 16 minutes is the time from B to C. We told ourselves that was the plan the whole time. Let's not mess around anymore. We're looking for 40% of 16 minutes, which translates to 0.4 times 16. Doing that together, we get 6.4 minutes. And boom. So the answer here would be 6.4 minutes. Nope, it would not, because again, they said nearest minute. So the answer is 6 minutes. So if you put 6.4, you were incorrect. The answer is 6, because it says round to the nearest minute right there. So guys, look, I'm really happy that I was able to show you, again, an easy version of these types of problems, mediums and hard, because I hope you see the clear difference between the structures of those problems. So in your opinion, what's the difference between, in your opinion, what you've seen, easy, medium, and hard math problems here? What's the difference? Oh, a headache just means that your brain's growing. It means you're getting smarter. More problems are more confusing, more work, more steps, the complexity. Yes, they definitely are more complex. Hard has a lot more to digest. Very, very, very true. Right, they're throwing more words at you. Look at all we needed to highlight here. We only needed to highlight certain sections here. And then obviously this part at the bottom that I erased. But half of this we didn't even highlight. It's crazy. Half of it we didn't even highlight. Now, let me ask you this, everybody. Does destination plan follow apply no matter what difficulty we're doing? It does. It does, doesn't it? Right? It applies no matter what problem you're doing. Exactly. And that's what I wanted to teach you today, everybody. It really was. This was my only goal for you today. Destination, plan, and follow. Because this doesn't apply just for SAT. It doesn't apply just to your math classes. It applies to real life in every situation. Assess before you react. Don't instantly grab your calculator or react to any situation. First, sit back and just analyze what's going on. How does this affect me? What am I trying to do here? What's the goal? Whatever you need to think about. And then work out those steps in your head and ask yourself, does this make logical sense in terms of trying to get the outcome I want? And if so, why? Can I convince myself that I'm right? And then from there, I'm going to follow my plan because I've built that confidence because I've asked myself over and over and I've proven to myself that I'm good. So that's what destination plan follow is all about. Let's start slow with what I understand. And then let's connect what I have to what I need to know using math. And then we're going to follow that plan. It's kind of like a jigsaw puzzle, guys. You don't want to do a jigsaw puzzle and then just try to start connecting random pieces. Think about it. That is honestly the easiest way to lose your mind, honestly. When you do a jigsaw puzzle, anybody here do a jigsaw puzzle? What do you usually go for first? What's the first thing you always go for in a jigsaw puzzle? I'm hoping that somebody here does jigsaw puzzles. Brittany, my girl, yep. Edges. We always start with the edges because that's the most easily recognizable piece. It can be upside down or right side up. We can recognize the edge pieces instantly. And so we start with what we're familiar with to turn a crazy complicated situation into something that's ordered and with discipline. Because the more you practice this technique, the faster you're going to get that 800 on the SAT math. And even if an 800 isn't your goal, I can guarantee you that this technique, when applied the right way, will raise your score. But you just have to apply yourself. So with that said, everybody, I had more problems planned here, but I do want to respect your time. I really do. We can save these other problems for the next webinar. I'm so down for that. But I want to ask you guys quite honestly, do you feel a little more confident with the strategy that I introduced today? Do you feel more confident? And I want you to give me a realistic answer. You know, use cap locks if you need it. I'm glad that you guys, benefited from this. I really am, because, for quite some time I've been working one-on-one with a lot of families, and I haven't really had the opportunity to make a standalone like website or something that everybody can get to, or like webinars like this. And so I'm glad that, with the Learning Liaisons, we've been able to reach more and more students like this. And you guys are the first group of a very special group for us. Because the thing is, who thinks that having like more of these types of problems would help you learn the math? Be honest. Do you think that if you had maybe like 450 problems like this, or 400 problems, that you would be able to use them and learn from them and apply destination plan follow? And now, what if you had video solutions to every single problem? Would that be fun too? Well, guess what? I made an entire thing. It's a bunch of problems. It's over 400 problems, video solutions, and you can download all the problems and practice yourself here on SATMathMadeEasy.com, guys. Yeah, thanks, Brittany. I really appreciate that. These sessions, again, they're all about helping you excel. And the thing is, look, this website that we made, it's perfect for you. You get to practice on your own, at your pace, on your time. If you want, I can always sit down with you and develop a study plan with you. Hey, these are the topics you want to do this week. These topics that week. This topic that week. And then from there, we can make that plan. Boom, you tackle those problems. You tell me how you are after a week or two. And then we keep making a plan moving forward. I'm here for you guys from start to finish. So with that said, because of this whole situation with what's happening in the world, we're not going to try to shortchange anybody. We're going to give everybody access to this at 75% off. Obviously, I know that not everybody here has that buying power, so talk to your parents, let them know what you thought of this session, and see if it's okay with them, if it's a right to try to get this with this code, stay at home, because you'll only be paying $7.50 per month. It's a subscription. It's kind of like Netflix, but for math. I have everything organized into a bunch of playlists. That way it's easier for you to just go in there, open the playlist, download the problems, try them all out. The ones that you got confused on, or the ones that you wanted clarity on, boom, you click the video for it, and that's it. It's that simple. And from here, we're going to attempt to make practice tests. We're going to make study guide sheets. We're going to make note cards. But this is the very beginning, and you guys are the special group that's part of it. So who's interested in something like this? Oh, Alexandra, I appreciate you guys showing up. You guys care about your futures. So like, why would I not give 110% for this? You guys are here, seriously, like in the middle of a global pandemic, the biggest that I've ever seen, that anybody of our parents have ever seen, and you guys are growing up through it. And I can't express how like grateful I am for a group of kids as brave as you, to, even though you don't feel these effects instantaneously, this is the biggest deal that you're ever going to go through. And I'm glad that you guys are still optimistic about being able to make progress and get ready for this test. I'm willing to cancel my Netflix subscription for this. That is hilarious. That is hilarious. So with that said, look, when you log in, or when you try to sign up, you can sign up for a free trial, but when you try to sign up for the free trial, it's going to try to charge you the full price after the trial's over. So what you need to do is make sure that you put in the code stay at home, all caps, no spaces, so that they can bring it down, not to $30 a month, but to $7.50 a month. Does everybody got that? It's going to stay at that price for 3 whole months. All right, so everybody got that? I want to make sure that we're all aware. I want to make sure that everybody has the right information, because I don't want anybody to really want this and then have to pay full price. No, you're not going to pay full price. That's wrong. Yeah, you're welcome. And quick question, is there a topic that you guys would like to see for another session like this? Because we might run one in like another 2 weeks. Okay. Yeah, because you guys should be trick stuff. Oh, for sure. I was thinking about putting trick stuff here, but that's like additional topics of math, and I had it like right here. Had some angle stuff and congruent stuff, and some shapes and volume. But with that said, what do you guys think about, having sessions where I release a practice test and then you guys do it on your own, and then the session would be to go over, a select number of questions? Yeah, Matt, probability is in the SAT. Long division of polynomials is on there for sure. You guys like that idea? Yeah, I think, is 35 years old too old to take the SAT? No, it's not. There's no age limit to take it. There is no age limit. I can go take it right now if I wanted to. And I probably will at some point. And because what was funny with me with the SAT, I'm going to reveal this, like this between us. I answered every question correctly. And I got one wrong because I didn't answer it. Because at the time when I took it, I'll ruin the curve. Because the thing is, when I took the SAT, they took points away if you got it wrong. So I was afraid, and I didn't answer a question because I was afraid of getting points deducted. And then I came back after I left the room, and I did the problem again, and I got it right. I realized that the answer I wanted to pick was right. And so I was one question away from like having a full ride to like MIT. So it was crazy. But Alexandra says, hey, that's so cool. Did you take it while yep, it was still at 2400 because we had the math, and then we had the verbal, and then we had the essay. So so with that said, guys, so look, we have an SAT parent group as well. I would love for you guys to join that SAT parent group, or if your parents could join that group, because we're going to be like posting ideas in there and asking your parents, what you guys would like to see up next. And so that group is going to be a really good way to keep a pulse on what we're doing. So I know it says SAT parent group, but students are more than welcome to join in there. If you have any questions, you can always, post it in the group for now. But we are going to find a way so that kids have a direct access way to us, and then the parents can stay in that group by themselves. Because we want to make sure that parents are getting parent information, kids are getting kid information, and that way everything's, efficient, and there's no like clutter or anything. But for now, we're perfectly okay with you guys joining the SAT parent group by the Learning Liaisons. That way, you can keep up to date with all of our webinars, all of our freebies, all of our group tutoring sessions, all that good stuff. Does that sound like a good idea, everybody? All right, sweet. Yeah, so go ahead and join that on Facebook. Hopefully we all have Facebook. So by the Learning Liaisons. And once again, guys, my name is Anderson, all right? My name is Anderson. If you have any questions, you can always reach out to me here at anderson@thelearningliaisons.com. We're going to be sending out an email pretty soon here with feedback, with this information again. And we're also going to be sending out the recording via YouTube. So we're going to upload it to YouTube. So like I said earlier, we posted it in the chat. But if you go on YouTube and look up the Learning Liaisons, again right here, go on YouTube, follow us on YouTube, subscribe to us on YouTube. There's an SAT playlist in there. We're going to upload this entire recording into YouTube. So follow us on YouTube, subscribe, like every video that you see. That way you can really get us going in terms of YouTube, so that more people can see what we've got going on to help you out. Exactly. It's going to be, because the thing is, going over a webinar live, like being able to ask questions, that's worth so much more than the recording, but the recording is already valuable as heck. It's valuable as heck. Milagros, I miss you. I haven't seen you in so long, and you live right down the street. But yeah, guys. So does anyone have any questions at all? Does anybody have any feedback or comments or questions at all? Please let me know before you go, because at this point, you guys are all free to go. We're going to be following up with you. But before you go, let us know. What did you think? Any questions, any comments? I am more than happy to answer anything. So Gift, we're planning on doing this probably once every 2 weeks. That seems like what I can handle right now, because just to make sure I'm being transparent with you. On top of this, I am a director of a company that teaches teachers. So I actually teach teachers math as well, so that they can get and keep their jobs. I also have a hand in AP calculus stuff and GRE stuff and my own personal tutoring business. So there's a lot going on. I'm going to do my best. But yeah, every 2 weeks is definitely doable. And then once we get a foothold on this, then we'll do it more and more, like once a week. Hey, I'm really happy that you guys found use in this. Because again, there's no point in me coming out here like not being excited about math. Like, I miss teaching in a classroom, but at the same time, I couldn't turn down this opportunity to teach teachers and make things like this for you guys. So it's it's bittersweet, but I'm glad that finally, I can bring it all together and get back to the kids. You guys, yep, again, you're welcome. You absolutely are welcome. I'm happy that you guys are here. See you. Yep, you guys can all sign out whenever you'd like to. If you have any questions, I'm here for you. I'm absolutely here for you. But again, satmathmadeeasy.com, that's the website you want to go to. Hop on that website, get that free trial, put in that code, and get started. Seriously, it's that easy. And it's only going to be $7.50 a month because, again, learning shouldn't be expensive. Hey, Catherine, I'm happy that I could be detailed. I'm glad that you were listening. That's what it's all about. I can take you to the moon and back if you're willing, and you were willing.